This is lecture 11 on urban transportation planning. We will continue discussing on trip generation analysis in this lecture also. Let us briefly recollect what we did in the previous class. We just took one numerical example of trip production involving only one independent variable, just to understand the basic analytical principles involved in development of trip production model. We found finally that in practice the example of this kind may not be directly applicable. We will have to deal with more than one independent variable, and sometimes it may be necessary to have different sets of independent variables depending on the trip purpose for which we develop trip production models. This implies that there is going to be a set of trip production models for a study area, trip production model for trips made for work, then another model for trips made for education, shopping, and so on. Now we are very clear about the statistical measures used normally to check the goodness of the regression analysis, starting from coefficient of determination, t-test, and comparison of standard error of estimate with standard deviation, and so on. We will just continue our discussion on trip production analysis, and I have just shown here another analysis named category analysis. Why category analysis, or what is the difference between the normal trip production analysis and category analysis? You may recall that the numbers that we dealt with in trip production model represented the average values, zonal average values. Zonal averages in fact may not be able to bring out all the different characteristics of households in traffic zones. For example, the average household size in two traffic zones could be 4, same average, but the range of the household size in one zone could be from 1 to 11, in another zone between 3 and 6. So practically there is going to be a distinct difference between these two zones, but we treat these two zones as similar zones for the purpose of trip production because we deal with zonal averages. And if you consider vehicle ownership, again taking averages will create similar problem. The range of vehicle ownership in one zone need not be same in another zone, even though the number will be same for any two zones considered at a time. So to take care of this particular problem of zonal averages not reflecting the actual household characteristics, many researchers based on practical studies have suggested another methodology of analyzing trip production following a different procedure, and this procedure is called category analysis. The main principle involved here is that the households are taken as basic units of trip production, whereas in the previous case we considered traffic zones as units of trip production, whereas here we take households as units of trip production directly and categorize the households based on their important characteristics. That is why this analysis is called category analysis. And most traffic analysis zones tend to contain a mixture of social and economic classes of people, as I indicated to you. The use of regression equations based on aggregated measures of zonal characteristics tend to submerge important characteristics of travel demand, because travel demand is influenced significantly by household size, household income, household vehicle ownership and so on. Since we deal with averages, the distinct characteristics or influence of these variables will not be reflected truly in the case of regression analysis. Hence, a number of transportation planners have proposed that this difficulty may be overcome by the use of households rather than traffic zones as a basic unit of trip making. That is the main difference between the previous analysis and this analysis. The basic unit of trip making is taken as household here, whereas previously we considered the basic unit as traffic zones. Let us see how to take basic unit of trip production as household and proceed with the analysis. It is very simple. There is no statistical procedure involved, simply observing the data and tabulating in a convenient way, so that we are able to understand the trip making or trip production characteristics of different categories of households, right. Thus, trip production modeling technique, which is based on the household and its characteristics, is known as category analysis or cross classification analysis, classifying households across various factors. That is why it is also called as cross classification analysis. Category analysis is simply a technique for estimating the trip production characteristics of households, which have been sorted into a number of separate categories according to a set of properties that characterize the household. Now, the question is, what are the properties that are to be chosen to characterize the households? This is where we need to be very careful in the choice of characteristics, so that we capture the trip production of households without much of error. Let us see how to go about doing this particular aspect. Of course, the results of category analysis for a hypothetical case as example is shown here to demonstrate to you how to go about capturing the appropriate characteristics of households in category analysis. Let us consider this table. On top, I have given the title for the rows as number of persons per household. We have considered 1 person household, 2 person household, 3 person household, 4, 5 and 6 plus. We have got 6 different categories of households based on the household size. That means household size is taken as a very important characteristic. And then number of motor vehicles owned by households, we have considered 3 categories: 0 vehicle owning households, 1 motor vehicle and then more than 2 motor vehicles, 2 or more motor vehicles. So, 3 categories of households, and I have just indicated under each vehicle ownership 3 letters as T, H and P. As you could read, T stands for trip productions of households in that particular category, H number of households in that particular category, and P educational trip production rate per household in category. This implies that it is possible to do category analysis for different trip purposes differently. In this case, it has been found that vehicle ownership and household size may be appropriate variables for educational trip production analysis, which may or may not be holding good everywhere. Maybe under our situation it might be different. This is a very general example I have taken from international literature, because I had the numbers so that it is easy for us to understand the procedure of doing this analysis. This is the value for no vehicle owning households of different sizes, and the number of trips made or produced are 240, and H stands for number of households of this category 800 households, and the trip rate comes to be 0.3 per household of size 1 with 0 vehicle ownership. If we look for the trip rate for households of 6 plus size with no vehicle ownership, it is 2.4. Of course, the average of the total comes to 1.35. If you put all the household categories together, taking vehicle ownership as the basis for all categories of households owning 0 vehicle, the trip rate for this particular purpose is 1.35. Clear? This is just based on the field observed data. Clear? We are just tabulating the field observed data.
So this is for
daily trip. Always when we say trip, it is daily trip made on a typical working day. Then if you consider one vehicle owning households, we find that for the same household size the trip rate is increasing. If we consider one person household, previously we found the trip rate was 0.3, here it is 0.875, clearly indicates the influence of vehicle ownership on trip rate. And similarly, if we compare the final value, it was 1.35 earlier, it is now 2.23. Again, the influence of vehicle ownership is significantly brought out in this particular case. And let us look at the details for households owning 2 or more motor vehicles. And for same one person household, you see trip rate is almost doubling compared to the previous value. It is 1.6 and 2.16 for 2 person household, 3.10 for 3 person household, and so on. And the average for all the household sizes owning 2 or more vehicles becomes 3.17, right. Now let us sum up along the columns also to look at similar averages for the set of data. We find for one person household, irrespective of the vehicle ownership, the average trip rate for education is 0.48. For 6 persons and more, it is 2.8, and the average in the last column is given as 2.23, right, irrespective of the vehicle ownership of the households. This is simply tabulating the available information, which provides us some basic idea about the trip rate related to the relevant characteristics of households. You can prepare similar table for work trips, shopping trips, and so on. Only a point to be noted here very carefully is we must choose the appropriate factors here. They have chosen 2 factors, household size and vehicle ownership. It need not necessarily be the same 2 factors for other trip purposes. That is the only difference. Now you may wonder why we need to consider households as trip making units, and how are we going to finally get the trip production rate for subsequent analysis. Because we have clearly understood earlier that your trip analysis is going to be zone based. We have understood trips as one way movements between zone centroids. There is no change in that particular analytical approach. Now we have come back to households and just getting information about trip production of different categories of households. ultimately we need to know the zonal level trip reduction. That is our ultimate objective. How to get that information from this table? This question has to be answered, otherwise our discussion is not complete. Let us take a small example and try to understand how to convert the results of category analysis into zonal trip reductions, right. Of course, information of the type considered in table may be translated easily into zonal trip reduction estimate. It is not easily, there is some procedure to be followed, and the number of households within each traffic zone that is expected to fall within each cell of the matrix, each cell of the matrix. 1 person household, 0 vehicle ownership, 1 person household, 1 vehicle ownership. That is how you must understand the cells of the matrix that we have seen earlier. The table is nothing but a matrix, isn't it? Otherwise I will just go back and tell you clearly what is understood by the cell. So each square is a cell because it has got a distinct identity. This number pertains to 3 person household owning no vehicle. So that is how we need to understand the cells in this particular table are estimated and multiplied by the trip rate, and these products summed up will give the zonal trip reduction. Is it clear? Maybe I will try to make it a little more clear with a small example. Let us say this is the information pertaining to a traffic zone. Number of households and total trips made category wise by household size and car ownership level. Household size considered here are 1, 2, 3, 4 or more, just an example. Number of households of that category, the numbers are given here. You can assume that this pertains to the whole of the urban area. Even though numbers look small compared to Indian scale, these numbers represent the whole of the urban area, either a town or city, right. And 2 person households 1471 and so on. Then number of trips made by the household, which we actually collect. The information is collected from the households by conducting surveys in the base year, so that information is provided. And similarly for 1 person and 2 or more person households we have collected the information. It is not 1 person, 1 car owning household and 2 or more car owning households. Number of households of that category is shown here, and then number of trips made by these households. The last 2 columns pertain to households owning 2 or more cars, isn't it? This is a total number representing the whole of the traffic zone. Can we just find out the trip rate for each of these categories of households from the given information? Just trip rate. What is the trip rate for 1 person household owning no vehicle? How do we get? Simply divide 1098 by 925, isn't it? Total number of trips made divided by the number of households of that category gives you the trip rate per day. We do this division for all the values and we can easily get the trip rate for each category of household. That is the first step. Clear? And if you do so, you will get a result of this kind. Household size 1, 2, 3, 4 or more, car ownership 0, 1, 2 or more, and we have got the trip rate for different categories of households. that clear? Now our interest is to get zonal trip production rates. You take a particular traffic zone, one zone, and find out the actual number of households belonging to each of these categories. That can be easily found, isn't it? You can find out in a traffic zone how many one person households own no car, how many one person households own only one car, and how many one person households are owning more than two or more cars, isn't it? So like that, do that for different household sizes 1, 2, 3, 4 and more, and get the actual number of households of each category. Then we have already calculated the trip rate for each of these categories and simply multiply these numbers by the corresponding trip rates. For example, we know there are 24 households in that particular traffic zone with only one person owning no vehicle. What is the trip rate for this household, which we have already arrived at? 1.19, isn't it? So 24 into 1.19 should give you the trip production for that particular household, right? That is what we do here. So we get trip production for the traffic zone by multiplying the number of households of that particular category with the corresponding trip rate. So finally it is possible for us to get zonal trip production values. This is our interest, 3109, that is what is our interest is really, isn't it? We would like to know total trip production for a particular traffic zone. Is that clear? Fine, and we have been discussing about different factors that influence trip production, starting from household size, household income, household vehicle ownership and so on. Let us look at some real life situation data pertaining to these factors that we have been discussing so far. I will show you one information about distribution of household size. We have been talking about one person household, 2 person, 3 person and so on. How exactly household sizes they are distributed in our country, in a particular town or city. I have information about one city named Tiruchirappalli. This city is in the geographic center of Tamil Nadu state. The population of this city is more than 1 million. Of course, this information is more than a decade old, but does not matter, distribution has not changed, and I am just going to use this information for comparison of similar information in a city in a developed country, and check where we are now and where we are tending to in the future. You can see that household size here is more or less normally distributed, right, and peak values are 4 and 5. Most common household sizes are 4 persons per household, 5 persons per household, and the other common values are 3 and 6. 3 and 6 are also quite common, significant percentages, and the distribution is just normal. When I just collected this data for a research purpose here, of course this data was obtained from the Department of Town and Country Planning, the government of Tamil Nadu. They had collected extensive data. The whole of the data was made available to us for doing some research, and that is how we got this information. Interestingly, at the same time I had a collaborative project in Germany, in one German university located in a city named Braunschweig. Braunschweig is in northern part of Germany, nearer to the city of well known city of Berlin, and I was also able to get involved myself in that planning work which was just going on. My counterpart was involved in the planning process, a professor in the Technical University of Braunschweig, and this is the information pertaining to Braunschweig city about distribution of household size. 1 person household nearly 45%, 2 person household around 30%, 3% only around 15%, 4 and more around 10%. Look at the distributions, distinctly different distribution, maybe negative exponential kind of distribution in that particular city. This distribution is reflective of the household size distribution in most cities in Europe, probably in America and Canada too. Why it is so? Why is such a significant proportion of 1 person household? Any response? Yeah, it is a very general but vague answer. I expect a specific answer.
Economic prosperity brings independence.
Good, more or less you are touching the right point. Economic prosperity brings independence. Then how economic prosperity and independence influence household size distribution? Both of you are more or less correct. There are cultural as well as economic aspects to this result. In most European culture, it is common practice to encourage children in families to go out of family as soon as they complete schooling and live separately under the remote care of the parents. This is partly a cultural aspect and partly because of some kind of economic independence. The objective of this kind of living, in my opinion, is to give youngsters freedom of thought as well as give them an experience of managing themselves, all the affairs related to their life, and in the process they try to be more and more independent. Initially parents support them economically, and in course of time they become economically independent too. They start earning while learning. They run their own household, and in the process they also choose their own life partners. They are independent, of course in certain cases with the advice of parents. And if you look at the way the elderly people live, parents of the parents, they do not want to live with their wants. Their age may be 80 plus or 90 plus, still they would like to be independent, living independently because they can support themselves economically. As long as they could move on their own, they want to live just independently without depending on their wants. So there are 3 generations living independent of one another. You can think of the household size. So that is the reason why the distribution of household size is distinctly different compared to what we have in our country. Living independently does not mean that they cut off their relationship once and for all. They fix specific days or dates to meet, spend some time together, enjoy a little bit, and then go back to their respective homes. Normally weekends you can see this kind of families coming together, 3 generations sitting together, chatting for some time, eating together, and then going back to their respective homes. Do you think that this kind of lifestyle is good or not acceptable? Why? Why not acceptable to Indian situation? Or in other words, why there is joint family system with more number of people in Indian families? What is the basic? Rather than stabilized, you can say the members of Indian families are not economically independent. As he rightly pointed out, once you slowly pick up economic independence, our Indian families also are likely to get scattered and the size will become smaller and smaller. That is a trend. We should anticipate as urban transportation system planners what is going to happen to the household size in our country in future, because we are planning for 20 years ahead. So we must anticipate a significant decrease in the household size compared to what is today, right? Grandparents sticking on to their wards and taking care of grandchildren, all these things are fine to some extent, but the bottom line is economic dependence. Once independence comes, you will find that families become smaller and smaller, household size decreases drastically. I do not know how many of you agree with my statement, but if you agree that generally socially and economically we are tending towards developed countries, this statement also holds good, right? Let us look at similar details pertaining to other factors that we discussed on trip production analysis. This is the recent information pertaining to this city, Chennai city. A comprehensive transportation study was completed in the year 2008 for Chennai city, and you can see the percentage of households of different sizes. Here also you can find 3% households constitute 40%, 2% households constitute 32%. This is a trend in most metropolitan cities in India today. Family size has already become small, 2% households 32%, and 3% household 40%, and 4% household 21%. Of course, this number 20,000 is the sample size. It is not the total number of households in the city. They have just taken 2% sample, so it is 2% of 10 million is 20,000, right? Yes, please.
So when we began describing the household, we also discussed about institutional households.
No, this is not including institutional households. This statistic is for a normal household.
Yes.
Okay, that is not inclusive. It is a good question. If you include institutional households, then the numbers may not reflect any meaningful result. That is why we are dealing with normal households. Institutional household statistics is not included here. Understand? Here we have the proof already. Just few minutes before I said we are tending towards very significant decrease in household size. It is happening right now. This is the income distribution in the same city based on the same study, CTS 2008. We find that about 25% of the households have income of 1,500 or less per month. This is the reality of metropolitan cities, even though when we look at the overall development etc., we get very green picture. If we get into economic aspects of the whole of the population, it is not that rosy, mainly because of the fact that nearly 1/3 of the population of most metropolitan cities in our country are living in slums. Okay. So that factor has to be understood very clearly. This is the metropolitan area, not municipal boundary. metropolitan area normally considered as a planning area for urban transportation system planning purpose. And other ranges you can see for yourself. Category B, income range is 1,500 to 3,000, of course it is much less. Category C, 3,000 to 5,000, significant, nearly 13%. 5,000 to 10,000, D is the predominant income range, more than 36% of the households have income of simply 5,000 to 10,000. 10,000 20,000 is around 14%, and 20 to 30 very small percentage, and 30 40 still smaller, 40 50 much less, and above 50 negligible. And this is the reality, but you must take these numbers with a pinch of salt. I have already told you, getting accurate information about income from the households is not that easy, right. So you can easily guess that these values might have been understatements. They would have given normally a lesser income value, or if you look at the information given by different sections of the society, it is likely that very low income groups give a little higher number and very high income group give lower number, that is also likely. So in general you must understand that these numbers are prone to error. We need not take these numbers very seriously, but still these are indicative of the reality, indicators, general indicators of the reality. One more information about trip production aspect. This is vehicle availability per household in Chennai metropolitan area. If you consider cars, we have 0.08 cars per household, and of course motorized two wheelers ownership is relatively high, 0.83 per household, and bicycle less than motorcycles. It is very interesting, only 0.28 per household. People do not like bicycle, they like motorcycles much, and other vehicles, three wheelers and other including animal drawn vehicles, okay. Other categories 0.02. Most interesting aspect is you compare these numbers with the previous value obtained in the year 1991 shown in the last column. You can find that the car ownership has simply doubled, right, and motorcycle ownership has quadrupled, become 4 times in a span of how many years? Just nearly 2 decades, let us say. In 2 decades car ownership is doubling and motorcycle ownership is quadrupling. It is a very high rate of growth of vehicle ownership, even though total number is less, rate of growth is very high. And bicycle ownership has decreased, has become nearly half of the previous value, 0.55 to 0.28. Of course regarding other vehicles they did not collect data previously. So we need to understand that there is significant rate of growth of motor vehicle ownership in our country. In spite of the low level of car ownership, our traffic in urban areas is not manageable as of today, and when the car ownership increases, what to do is the question. Maybe later we will discuss about the implications of planning on traffic management when we discuss about sustainable transportation system nearly at the end of the course, right. Now one additional information which may be of interest to us in connection with trip production is this. Daily trip production details of Chennai metropolitan area are shown here. Household size is given from 1 to 6 as well as 7 and above. The number of households in each category, same as we have seen earlier, total number is 20,000. The number of person trips made by households of different categories, 1 person household, 2 person household and so on, and then person trips per household is given, the last but one column. Last column gives the per capita trip rate, trips made by 1 person per day. In a particular household, right. And you can see as the household size increases, the trip rate comes down. Initially it is 2.2, of course in the case of 2 person household it is slightly more, otherwise there is a decreasing trend, 1.6, 1.3, 1.1 and then 0.9. Our interest is the average of all. The average per capita trip rate today is just 1.62 trips per head per day. If the population of this metropolitan city is taken as 10 million, then roughly 16 million trips are produced per day, and we have to provide for, or we have to meet this demand of 16 million trips which is produced every day. That is the total demand, and we must meet this demand by planning an appropriate transportation system. If the total demand can be met by a simple means, then it is easier. If the total demand for Chennai city of a particular commodity is known, you can easily procure that amount of the commodity and distribute easily. Let us say for example demand for rice, the whole of the city, sugar or some other commodity, you can procure the whole lot and store the commodity in the warehouse, identify the distribution centers and distribute the commodity. Total demand is known and distribution centers are known, you can just distribute, meet the demand without much of difficulty. Can we do in a similar fashion to meet the transportation demand? 16 million trips per day, okay, provide enough number of vehicles to meet this many trips. Is that the way to meet this demand? Demand for transportation is a very complex commodity. Why? Why it is complex? Because as I said earlier, demand for transportation is spread over space and time. Each trip is different from one another. If you take a particular trip, there are a set of attributes for a trip: the origin, destination, time of start, time of finish, mode used, transfers made between modes if necessary, right. So these are all the attributes of a trip. These attributes are different for different trips. So when such is the situation, how to meet this kind of a demand? Each one would like to go from one point to another point at a particular time using a particular mode of transportation at a particular time period. That is where meeting transportation demand becomes extremely difficult, and you cannot treat demand for transport as simply demand for a general commodity. It is a very complex commodity and we need to have our own methodology of meeting this demand. Later on in the course of our discussion we will know how to really meet the demand for transportation by appropriate planning procedures. So this completes our discussion on trip production analysis. You may recall we started our discussion on trip generation analysis, and trip generation has got two parts, trip production and trip attraction, right. So, this means that we have completed our discussion only on one part of trip generation analysis. Let us look into the other aspect, trip attraction analysis. You may recall trips associated with non-home zones or trip attractions, or non-residential zones or trip attractions. We have managed to identify factors that influence trip production. All the factors are related to household characteristics. On the same lines, is it possible to identify some factors which might influence trip attraction? Since trips are attracted by non-residential zones, household characteristics cannot be taken as factors influencing trip attraction. We must look for some other set of factors. Any suggestion? We need to look for land use characteristics, the factors that are reflecting the type and intensity of use of land uses will be useful for us to explain trip attraction. Land use characteristics influence the trip attraction rate in urban areas, and we have already classified the urban land uses into different types, starting from residential, commercial, industrial, institutional, recreational, and so on. Now, it is a question of deriving or identifying some factors associated with these different types of land uses, which will really influence the trip attraction, right. Of course, we are going to leave out the first category, residential, because that is related to trip production, right. We must look for factors associated with other land uses, commercial, industrial, institutional, recreational, and so on. Can we think of some factors reflecting the extent and intensity of commercial land use? It need not be at a disaggregate level. You need not have to worry about different types of shops that will be available in commercial area, total number of shops and things like that. Some aggregate information reflecting the type and intensity of land uses. That is what we are going to use in trip attraction modeling. I will give you some examples. Identifying causal variables for trip attraction analysis. Retail trade floor area. It may not be very specific and very accurate, but still in the absence of accurate disaggregate information, we must go in for some kind of approximate aggregate information. In that context, this will be more appropriate. Retail trade floor area. You have number of shops, at least the floor area of all the shops together will give you some idea about the intensity of this particular land use in that traffic zone. Similarly, service and office floor area, in the case of institutional land uses. What is the spread of these activities, office and services? Then manufacturing and wholesale floor area. If you are looking for some factors in industrial land use, look for floor area which is actually used for manufacturing purpose, wholesaling and so on. Then The other way of looking at the intensity of land use at non-residential end is look at the number of employment opportunities in retail trade. You have commercial area, if more number of people are employed in commercial activity, that is also reflective of the intensity of commercial activity in that area. So this is also possible. If you get accurate data of this type, that can also be tried out as a factor influencing trip attraction. Number of employment opportunities in service and office, similar to the previous one. And number of employment opportunities in manufacturing and wholesale. In the case of educational institutions, school and college enrollment, number of students attending a particular school, college in a particular traffic zone will be a good indicator of its ability to attract trips. Most of the educational trips will be attracted towards that particular zone. So college or school enrollment could be a very important factor, and in addition to the zonal characteristics, there could be some special factors like this. We have intercity bus terminal located in a particular area in a city. People making intercity trips will be converging towards that particular point. So one traffic zone, okay. Like that, number of special activity centers like transport terminals, railway stations, bus stands and so on, sports stadium, major recreational, cultural and religious places. If such activity centers are located in zones, you must include this fact also into your modeling process, so that ultimately you get fairly accurate value about trip attraction of a particular zone, right. To summarize what we have seen in this class, I would say that first we discussed about category analysis as a substitute for normal regression analysis of trip production. We know the basic difference between regression analysis and category analysis in respect of trip production now. Regression analysis is zone based, whereas category analysis is household based. We should also realize the fact that even though we do category analysis based on household or taking households as trip making units, finally we need to convert the information that we get in category analysis into zonal information to get ultimately the zonal trip reduction rates. Then we saw a set of interesting examples of household characteristics, starting from household size, household ownership, vehicle ownership and household income and so on. And the moral of the story is that the household characteristics of developing countries are tending towards the household characteristics of developed countries, and as planners we must understand the trend or the change in the different characteristics of households and understand the possible future scenario and incorporate that information in the planning process. Finally, we discussed about trip attraction with specific reference to identification of different factors influencing trip attraction. We will continue the discussion on trip attraction in the next class. We will sum up our discussion for today with this.